Welcome back, everybody. We are continuing our quadratic functions, and today we're going to talk about solving by graphing and factoring. Pause the video for a minute and jot down your vocab at the top. And in our steps for solving by graphing, probably the key thing that we have to make sure that we do is make sure that it's equal to 0 and that we have written in standard form as much as possible, ax squared plus bx plus c. When we take a look at our graph then, wherever it crosses the x-axis, our x-intercepts are the roots or solutions to the quadratic function. So let's give it a try. Let's say we have this quadratic, and right now we have it equal to 3. We need to subtract 3 to the other side, so that way it's equal to 0. And now we can graph this. Well, what do we know? We know that our y-intercept is at 0, -3, because c is -3. We know we can find our vertex using -b over 2a. Our b is 2 and our a is 1. That's -2 over 2, which is -1. The x value of our vertex. And then remember to find our y value. We plug that -1 in for all of the x's of our equation and do that math. We have 1 minus 2 minus 3, which is -4. So we have a vertex at -1, -4, and a y-intercept of -3. We know because of our axis of symmetry that if we have 0, -3, we would also have -2, -3. So if I were to draw this graph, do I have x-intercepts? Well, yes, I do. There's one right here and one right here. Now remember, we're graphing, we're estimating based on just the vertex and the y-intercept that we could find. So we're estimating our x-intercepts to be, let's say, -3, 0, and 1, 0. X-intercepts are our roots or our solutions to this quadratic function. And again, we're estimating because we're not 100% sure. We're sketching a graph. So graphing, unless you're doing it in a calculator and you get exact answers in there, it's probably not going to be the best way to go about doing this, but it's a way for us to get started. Let's try this next one. We again want to make sure that it's equal to 0, and right now it's equal to -16. So I'm going to add 16 over. That's x squared minus 8x plus 16 is equal to 0. What do we know? Well, we know our y-intercept is at +16. Our vertex, -b, which is -8, over 2 times a, which is 1, gives us +8 over 2, or 4. So our vertex is at 4. We plug that in for our y, 4 squared minus 8 times 4 plus 16, and gives us 16 minus 32 plus 16, which is 0. So a vertex of 4, 0, and 0, +16 is way up here. That also means we'll have 8, +16 way up there. And so this is our graph. Do we have any x-intercepts here? Well, actually, yes, we do. It's right here. Our vertex is an x-intercept. So our x-intercept, root, or solution is going to be 4, 0. Let's try this last one. Negative x squared is 2x plus 4. I'm going to bring this x squared over to the right to get my 0, and then my standard form on the right side. So again, what do we know? Well, we know that our y-intercept is at 0, 4 because c is positive 4. For our vertex, we have x is equal to negative b over 2a. That's negative 2 over 2, which is negative 1. And then our y value, negative 1 squared, plus 2 times negative 1 plus 4 gives us 1 minus 2 plus 4, which is 3. So negative 1, 3, and 0, 4. That means we also have a point at negative 2, 4 because of our axis of symmetry. And there's a rough sketch of our graph. What are our roots, x-intercept, 0 solutions? And we can see that our graph is not going to cross the x-axis right here. And so if it doesn't cross, then we have no real solutions because our graph is not crossing that axis. All right, I would like you to try number 3, please, for class. So to sum up what it is that we would be able to see on our graphs, we would have 2 real solutions. When the graph has 2 x-intercepts, we can see it crossing that x-axis twice. 1 real solution when the graph has 1 x-intercept, like that second graph that we did where it only touched the x-axis once. And then no real solutions when we have no x-intercepts. And again, the keywords there are real because, like I said on the last chapter, we focus on the word real because later on, and we get into Algebra 2, we'll start talking about imaginary values. All right. So factoring. How does factoring help us solve on a graph our x-intercepts or roots or solutions? Let's start with factoring. So if I factor this, there was no greatest common factor. 1 times 35 is 35. 2 numbers that multiply to 35 and add to 12 are going to be 7 and 5. We keep our x squared plus 7x plus 5x and keep that plus 35. 4 terms split in half or factor by grouping. Our GCF on the left is x. Leaves us with x plus 7. Pull down the plus sign. Our GCF on the right is 5. Dividing by 5 leaves us with x plus 7. So our factored form here is x plus 7 times x plus 5, or x plus 5 times x plus 7. So now if we graph this quadratic, well, again, what do we know? Well, we know that our y-intercept is at 0, positive 35. Great. We can do, for our vertex, negative b, which is 12 over 2 times a, or 1. That's negative 12 over 2, which is negative 6. Plug in our negative 6. We have negative 6 squared plus 12 times negative 6 plus 35 equals y. I'm going to put all of that in my calculator, and I end up with negative 6, negative 1. So I'm going to go ahead and put this right here. I really don't want to use that 0.35. So instead, with my negative 6, negative 1 in the middle, think I'm going to pick -7 and -5 to plug in for my x's. So if I plug in -7, we have -7 squared plus 12 times -7 plus 35 in our calculators. We end up with 0. And then that -5 would also have to be a 0 then. So there's those 2 points, and here's our graph. But what do we notice about these two x-intercepts? Because remember, this is our x-axis right here, and these two values right here. Well, what I notice is that's a +7 and a +5 in our factored form. And on our graph, our x-intercepts are a -7 and a -5. So they're the exact same value, just opposite signs. And there's a reason for that. It's because of the zero product property. And so you can read through that stuff at the top of your notes, but basically, let's just dive right in and get to our factoring and why this works. Remember, we're not focusing on this equals 0. We're only focusing on the left side. Is it in standard form? Yes. Is it equal to 0? Yes. Do we have a greatest common factor? No. 1 times 12 is 12. Two numbers that multiply to 12 but add to -8 are going to be -6 and -2. Keep the x squared, -6x minus 2x, and keep that plus 12. 4 terms split in half for factor by grouping. Our common factor on the left side is x. Remember, that means we're dividing by x, and we're left with x minus 6. Bring down the minus there. Our GCF on the right side with 2x and 12 is 2. Remember, it's -2 because of the negative in front, which is going to change our signs, and we have x minus 6. So our factored form, we have x minus 6 times x minus 2. And now we bring back that equals 0. Well, what does that mean? That means that we take each of these factors, set them equal to 0, and solve for x. We would add 6 to get x alone, and x is equal to 6. Add 2 so that x is alone, and x is equal to +2. And that's how we end up with our opposite signs. They were minus and minus, now they're both positive. Let's take a look at example 2. Do we have standard form? We do. Is it equal to 0? Yes, it is. Do I have a common factor with 2, 11, and 12 that I can pull out to reduce my numbers? No, I do not. 2 times 12 is 24. Two numbers that multiply to +24 and add to -11 are going to be -3 and -8. Keep your 2x squared. We have minus 3x minus 8x. Keep that +12. 4 terms split in half for factor by grouping. Our GCF on the left side is x. Leaves us with 2x minus 3 when we divide. Pull down the minus. Our GCF on the right is going to be 4. Remember, we're dividing by -4, which changes those signs to a +2x and a -3. Now our parentheses are the same. We have 2x minus 3 as one of our factors. X minus 4 is the other one. And then we bring back that equals 0. Now that we've brought back that equals 0, we can take each of the factors and set them equal to 0 to solve for x and find our roots, x-intercepts, or solutions. I'm going to add 3 to both sides here. 2x is equal to 3. Divide by 2. And we have x is equal to +3/2. That's one of our x-intercepts, roots, or solutions. Add 4 to get this x alone, and we have x is equal to +4 as our other x-intercept 0 root or solution. So if we were graphing, we would now be able to take these, plot these on our x-axis, and we have our c value, so we know what our y-intercept is as well, and it can help us with our graph. Number 3, what should this be equal to? Well, it should be equal to 0, and it's not. So we have to start with moving that 45 over with the rest of that for standard form and having it equal to 0. So now I have standard form. It's equal to 0. Is there a common factor I can pull out of all of that to reduce my values? No. 1 times negative 45 is negative 45. Two numbers that multiply to negative 45 and add to negative 4 are going to be negative 9 and positive 5. Keep that x squared minus 9x plus 5x. Keep the negative 45. Split that in half. Your common factor on that left side is x. Pull out x, we're left with x minus 9. Bring down that plus sign. Your common factor on the right is 5. It's a positive 5. Leaves us with x minus 9. My factors now match, so one of our factors is x minus 9, and the other one is x plus 5. Bring back that equals 0. Now we can set both factors equal to 0 and solve for x. I'm going to add 9. 0 plus 9 is 9, so x is equal to positive 9. Subtract 5 from both sides over here, and x is equal to negative 5. So our root solution, 0's x-intercepts, are positive 9 and negative 5. Number 4. What's the first thing that we always check for, besides the fact that it's equal to 0, is we check for a GCF. And standard form equal to 0, we do have a greatest common factor of x. That means we're dividing by x here, and we're left with x minus 8 is equal to 0. Well, that's all the factoring that we can do here, because I no longer have a square or anything. Now we set both factors equal to 0 and solve for x. Well, this factor over here on the left, x equals 0, x is already alone. So I know that 0 is one of my root solutions, x-intercepts. On the right side, we would add 8 and add 8. X is equal to positive 8 as our other x-intercept root solution. All right, go ahead and give number 5 a try, and I'll see you in class. Thanks so much for joining me. Have a great rest of your day.